In this video, we're going to go over section 4.4 from our textbook, which goes over some polynomial equations and inequalities. And so throughout this video, we're just going to go over several examples that are going to be similar to those that we'll see on the homework. So first, we're going to talk about an equation quadratic in form. So an equation will be quadratic in form if it can be written as this here, where a is not equal to 0 and u is an algebraic expression. And so this is our standard quadratic equation in standard form. So we're going to look at this example here. We have this equation, and we want to figure out for which values of x will make this equal to 0. And the first thing to notice here is that this is an equation that is quadratic in form because we can rewrite it as the following. Now, if we were to let u be equal to the algebraic expression x squared, we can rewrite this guy as u squared plus 2u minus 8. Alright, so we just use the fact that this equation is quadratic in form to rewrite it in this way, so that'll be a little bit easier to solve. All we have to do is factor this guy, so we'll get u minus 2 and u plus 4. So this tells us that in order for this to be equal to 0, either u is going to be equal to 2, or u is going to be equal to negative 4, or both. But remember, we said u is equal to x squared, so this means that x squared is going to be equal to 2, or x squared is going to be equal to minus 4. Now solving for x, we'll get x is equal to plus or minus the square root of 2, or x is equal to plus or minus 2i. And then we can conclude that our solution set are going to be those four values. So minus square root 2 minus 2i, positive square root 2, and positive 2i. Alright, let's look at another example. We want to solve this equation here. We want to figure out for which values of x will make this be equal to 0. And so in this case, what we'll do is we'll factor by grouping. We're going to group these terms, x cubed and minus 2x squared, and the terms minus 3x plus 6. And the reason why we're going to group these guys is because we can see that both of these has a factor of x squared, both of these terms, and both of these terms have a factor of 3 in them. So we can easily pull those terms out. We'll get x squared times x minus 2 on the left, plus pulling out a minus 3, we'll get x minus 2 on the right here. So this is going to be the same as x squared times x minus 2 minus 3 times x minus 2. Alright, and then notice that both of these terms have an x minus 2 in them, so we can pull that guy out. And so we get x minus 2 times x squared minus 3. Then we can easily see that this means that x is going to be equal to 2, or x squared is going to be equal to 3, which tells us x is going to be plus or minus square root of 3. So then our solution set is going to be minus square root of 3, positive square root of 3, and 2. Alright, let's look at another example here. We want to solve this analytically. So the first thing that we're going to do is move all of our terms onto one side and set this equation equal to 0. So if I add 18 to both sides and subtract 12x squared to both sides, we'll get 2x cubed minus 12x squared plus 18x is equal to 0. Now notice every single one of these terms has a factor of 2x, so we can pull that out. We'll be left with x squared minus 6x plus 9. Now this becomes much easier to factor. We just need two numbers that will multiply to be positive 9 and add to be minus 6. So that'll be x minus 3. Alright. And then rewriting this in simpler terms, we'll get x minus 3 squared. And if you remember from the last video, this means that this 0, x is equal to 3, has multiplicity 2. So then our zeros become 0 here and positive 3. And so our solution set is 0, 3. All right, and the very last example we're going to look at is this one here. You'll see several like this on your homework, but we want to solve the equation and the inequalities using the graph of this polynomial here. So we're given this polynomial, and what we're going to want to do is graph it. So the graph of this guy is on the left here. We can see that we have zeros 2, 1, and minus 2. And we can see that's the case here as the graph intersects the x-axis at those points. And for part A here, what it's asking us is to determine when our polynomial equation is going to be equal to 0. And like I just said, that'll happen when our graph intersects the x-axis at these points here. So for A, our solution set will be minus 2, 1, and 2. Now for B, we want to figure out when our when our polynomial function is going to be less than 0, so when it's going to be negative. So we know all of our output values are going to be negative when we're below our x-axis. So it's going to be all of these and these guys here. So p of x is going to be less than 0 or negative when x is less than negative 2, and when it's between 1 and 2. And then in interval notation, when x is less than negative 2, that's going to be negative infinity up to negative 2. And then when x is in between 1 and 2, that's going to be 1 to 2 here. And lastly, we want to figure out when all of our output values are going to be greater than 0 or positive. We know that's going to occur for everything above the x-axis here. So it's going to be all of these guys and all of these guys here. Alright, so that'll be when x is in between negative 2 and 1 here. So in between these two guys. And when x is greater than 2. And then in interval notation, this will be negative 2 to 1, and then 2 to infinity.